Hey, BC Calculus, Mr. Allinger here, and today we had our test. Hope it went well. And then to follow up on it, then we had a little introduction. If all goes well, this is me talking actually before it happens, but we're going to show you the chain rule. And so you've learned the chain rule at this point, and now it's just a question of getting a chance to see some examples. So I haven't written it down on here, but just a reminder of what the chain rule says is that the derivative of a composite function, a function of a function, or you can think of a function that happens first, we call that the inside function, and then another function that happens to that, that's the outside function. That the derivative of a composite is the derivative of the outside with the inside intact times the derivative of the inside. And this video is just going to run through some examples of that so that you can try a few on the homework and just kind of get an intro to chain rule. And then next class we'll finish up chain rule and we'll even dip our toes in the water of the next section. All right, so yeah, this one really opens up a lot of functions because we've never been able to have a function inside of a function before. We had it on one problem, and I kind of said, "Don't worry about that," and we kind of said, "Okay," but now we're doing it official. So when you're looking at a problem like this, the key thing to do is to identify what's the outside and what's the inside, and then just know the chain rule. So it's a derivative of the outside. So I'm doing the derivative of sine of something, and I don't worry about what that something is. And so I just say it's cosine of something with the inside intact times the derivative of the inside. And that's the chain rule. Now what I'd like you to do is, why don't you try some of these examples right now? I'm just looking at, one thing I'm just realizing on this one, it looks like this one, I think that would be a little more interesting, so let's do that. So the whole thing is squared. Oh no, I got squared down, never mind, I got squared down below. So that's sine of 3x squared, that's what that is. Okay, we got that. Yeah, this is all good. So this is outside, inside stuff, and just take the derivatives, pause the video, and then we'll show you the answers. All right, so I'm just doing the answers right now, so you should pause me. All right, so again, it's cosine, that's the outside still, and then 3x squared. I'd probably do some algebra first and just say, well, that's 9x squared. And so it's cosine of 9x squared, or you could have written it the old way, times the derivative of what's inside. Okay, so moving that square didn't change what was outside, so that was okay. If you approached it the other way, if you said, I want to have something in like three functions, there's an inside and then one layer out and then another layer, so it's a function of a function of a function. We'll take a look at that in class. Let's leave that off for right now. All right, next one. This isn't chain rule at all, so that's what I'm kind of messing with you on here, is that this is just a constant, because sine of 3, plug in your calculator, you get an answer, remember 3 radians, times x squared. This is just the constant multiplier rule. So it would be sine of 3 times 2x. Next one, okay, I got to think of this. This is sine of x squared. So the outside function is squared. And so the derivative of that is multiply the 2 down, drop the exponent by the 1, but the chain rule says leave the inside alone at first, and then do the derivative of the inside, which is cosine of x. And if you're a spiffy person and you remember your trig identities from last year, you'll remember that that's equal to sine 2x. Just a little reminder on that. But yeah, so that's a derivative. Nothing else to say. All right, derivative of this. Now this is kind of confusing. What's the outside? What's the inside? And so think to yourself, what happens first to the x? That's the inside function. Like going up here, what happens to the x first is what's inside. So what happens to x first is squared on this one. And what happens second is e to the. So the derivative of e to the anything is e to that thing times the derivative of what's inside. Next one, derivative of natural log of 5x. There's a lot of ways to do this one, but I'm going to do it with straight chain rule here first. So it's 1 over, that's the derivative of natural log of something is 1 over something, and I leave the inside alone, times 5. and the 5's cancel out, and it's equal to 1 over x, which is kind of interesting. Like, where did the 5 go? You know, the 5's gone in the answer. Like, that could have been 3 or 4 or 5 or pi or anything, and the same thing would have happened. Well, let me show you why. One way I could have done this problem is I first could have done some log algebra to rewrite the natural log of 5x. Take a moment, see if you remember your log rules. Well, that's natural log of 5 plus natural log of x. Right? Now I could take the derivative of it, and since this is a constant, that would just go away, and you do the derivative of natural log, and you get 1 over x that way also. So it's kind of cool, like the algebra rules we learned before are being kind of backed up by the chain rule, that those things are equivalent, that natural log of 5x is the same as natural log of 5 plus natural log of x. Okay, how about natural log e to the x? Okay, if you were sharp on this one, then you spotted not if you're smart, but if you're thinking like big picture and not just focused on the chain rule, then you might have done a log property here, but I'm going to ignore that for a moment, and I'll say, okay, natural log of something is 1 over that thing times the derivative of what's inside, which is just e to the x, and I get 1 as an answer, which makes me awfully suspicious that something like the last problem just happened. So I go, okay, well, let me see this. What if I did a log property here? How could I rewrite that? Well, you could pop the x in front, and it would be x natural log of e. Remember the log of an exponent goes in front, it's multiplier. And the natural log of e is just 1, so it's the derivative of x, which is 1. Just a couple log properties thrown in there to cheer up your day. I don't know, maybe it cheers up my day a little bit. But it's great the way all these systems that we've learned in these different places all are backing each other up. And that's the cool part of math, right? Okay, so the purpose of this short video was just to go through some examples of chain rule. We're going to do some more chain rule stuff next class, but for right now, I just want to give you a few more examples so you could do a few problems tonight, just kind of getting started with chain rule a little bit, and then we'll finish it up next class. But all chain rule really is how to take the derivative of a composite function. And it's huge, like chain rule. We're going to be using that one all year. And so there you go. So take care. Hope this goes well, and it's not and it's like a kind of an easy night homework. And then we'll see you on Friday. Take care. Try to hit the pause button.